F and G are differentiable. That means you can find F prime and G prime, or it understood to have the F prime and G prime available. At the x equals 5, the F at 5 is 10, G at 5 is -3, F prime is 1, G prime at equals 8 at the same point at x equals 5. And you are going to find H prime at 5. The first part, the H is in the quotient form, okay? The quotient form, and it's directly in the form of the F and G. This one I'm going to put a note. This is a quotient form. Okay. If we see as a quotient form, your goal is to find the S prime. Your S prime or the derivative of the S, you're going to use the quotient rule. The quotient rule that we use all the time, that I use in the class all the time, that's high and low. The low, d high minus high, d low over low squared. And this is different than the earlier problems that we did because you do not have the actual function. You just have the value for each one of them, including the derivative. So I'm going to replace the L with the G. I'm going to put a G of X and multiply by the H prime, which is the derivative of the F, subtracted by the H, which is the function F, and then multiply by the derivative of the low, which is the derivative of the G. Basically, it's back to one of the forms of the quotient rule, and the low is the G. Why I go back to F and G? Because all information are provided in form of the F and G term. Okay, now we get the right template, but we are going to find when x equals 5, okay, because the goal is to find h prime at 5. Wherever you see x, you replace with the 5. Just get the placeholder for now. We don't replace any value yet, okay? Just do one step at a time. Okay, and then after this step, you know the position of the G, the F, the F prime, the G prime. So I missed the prime here, the prime. From information provided, the G at 5, what the value for G at 5 is given to be -3, right?
Yeah.
-3. What
Mm-hmm.
is the value for F prime at 5?
1,
1. What is the value of F at 5?
10,
10. The value of the G prime at 5
8.
is 8. How about the G at 5 one more time here?
It's 5, right?
This
And
-3, right?
yeah.
The G at 5 is -3, but we have to do the power 2. So
Okay.
now what we can do for the next step, we just clean up the value. So we're going to have -3 multiplied by 1 minus 10 multiplied by 8, all divided by -3 to the power 2. And then, I don't want to go over to the next one yet. So try to keep it in the same frame. So simplify the number, order of operation, PEMDAS. Think about PEMDAS, what you have to do. Parentheses, exponent, right? And then MD, that is the multiplication and division. You do the multiplication first. So that means you work on the product first before you do the subtraction. So it's going to be -3 minus 18. Not 18, sorry, I'm wrong. So the
80.
10 times, yes, it could be 80. It's my bad again. So -3 squared, that's positive 9. And then clean up the number. You should get -83 divided by 9 as the result of the h prime at 5 for part A. Okay.
I think this example easier than another one. Like we don't have to multiple so much. We don't have to add so much.
So both of them like based on the same formula, depends on what information provided. Okay, let's see another one. Another one is the product form. I'm gonna bring this up and then copy down what information that we have from the problem. Okay, to keep everything in one screen. So on my side notes here, I have f at 5 equals 10. The f prime at 5 is 1. The g at 5 is -3. The g prime at 5 is 8. So those are numbers that provided. This time, the h is not in a quotient form, but in the product of the f and g, they're all over the place. So your goal is to find h prime at 5. Same goal, but different form of the h provided. From what you see here, you see the product of the g function and the quantity that has f involved. So I put pieces here. One piece has the f and the 3x and -1 all together as one quantity. And the other piece is just the standalone, the function g. So I treat this as I see in the product form. When I see the product, I'm going to use the product rule. And the product rule, even though it's not as bad or as complicated as the quotient rule, but the one that make it complicated is the term that has both f and other thing together. So just to make our life easier, I'm gonna rename, instead of using the lowercase f and lowercase g as we always do, I'm gonna use the uppercase f and uppercase g. Okay. So then my one quantity together as the uppercase f is the lowercase f plus 3x minus 1, and my capital G, which is the same as the function g. To find the derivative of the product using the product rule, so h prime of the x gonna be, for this case, since we use different form, the uppercase version, gonna be 1 multiplied by the derivative of the other. So let me put in the, there you go. So I'm gonna put as the f multiplied by g prime plus the f prime multiplied by g. Just the mix and match as before. So that means I'm gonna need to complete my f prime, which is the derivative of whatever that I have in there that form to be the capital F function, which is the derivative of the function f. It's kind of further prime here, right in the better one. So gonna be prime of the f plus the derivative of the 3x minus 1. I hope Ryan is okay with this. The derivative of the 3x minus 1 would be 3, right? Yes, very good. And then the capital G gonna be the prime of the capital G is the same as the prime of the lower g because they are the same. I get my prep work. Now I'm gonna bring it into my template when I have to use the product rule. My quantity for the f, parentheses, remember, keep it as a habit. So this is the f plus the 3x minus 1, and then multiply by the g prime, which is the g prime x, the lowercase g prime x, and then plus, I put here parentheses here, and then the f prime, which is the quantity of the prime of the lowercase f plus 3, multiplied by the g, which is the lowercase gx. I put everything in my placeholder. Okay, this is for the general derivative of the h at x, any x. But now I'm gonna look at the term, the derivative when x equals 5. That means when h prime at 5 that we have to compute, we're gonna replace, wherever you see x, you're gonna replace with the 5. 5, 5, 5 here. Okay. Right now we still have just use the placeholder, not the given set of the values yet. Okay. So changing from the x notation into the 5 notation. So f of x become f at 5 plus the 3 multiplied by 5 minus 1 multiplied by the g prime at 5 plus the f prime at 5 plus 3 multiplied by G at 5. Okay. And then after this step, you just go back to look at the numbers for each term that's given by the problem. So for the f at 5, this is 10. The 3 times 5, that's 15. The g prime at 5 is the value 8. F prime at 5 is 1. The g prime at 5 is negative 3.